Okay. Hey everyone, Miss Sola here with the very last lesson of 2025. This is again part of our little extra unit. This is Z scores. So continuing from what we talked about last lesson, my data distribution, but specifically only with the normal distribution. So the ones that have the shape that the data kind of follows, goes up and then back down with my histograms. This is E2. So your Z-score, there's a couple kind of words to define here. I'm gonna draw a really big normal curve just to kind of, so we can fit everything in it. The middle. So I'm gonna go up to the top to that and then back down as symmetrically as you possibly can, team. As symmetrically as you possibly can. All right. Now on this graph, a couple of things to keep in mind. Now, this is based on a histogram. So there's not a lot of data that fall over here on the low side, and then it gets bigger and bigger as you get closer to the mean, which is in the middle. We use that symbol for mean, mu. And once I get to the mean, a ton of data here, like the frequency of data points here is very high, and then it starts going back down. So not a lot of people really, really high, not a lot of people really, really low, lots of people in the middle. That's the goal. And in a normal distribution, this doesn't always happen. You can't just make data normal. But when I do have a normal distribution, the standard deviation becomes really important. So I'm going to break this into some pieces here. 1, 2, 3. Evenly spaced as best you can. 1, 2, 3. Evenly spaced as best you can. So let's say this distance here between the mean and this first dash, the distance here is 1 standard deviation. Here's my red pen, very bold here. 1 standard deviation. From here to here. 1 standard deviation. Okay? 1 standard deviation away from each other. 1 standard deviation away. Each square is 1 standard deviation away from each other. Okay? So that means the where this one is here is your mean plus 1 standard deviation. And this one is going to be your mean plus 2 standard deviations. And this one is going to be your mean plus 3 standard deviations away. Because 1, 2, 3 standard deviations away from the mean. And the same will be true on the other side. So my mean is most of my data is here. On average, we're here. 1 standard deviation less is going to be your mean minus 1 standard deviation. This one will be your mean minus 2 standard deviations. This one's going to be your mean minus 3 standard deviations. So all of your data is falling into these bins, I guess, if you will. 1 standard deviation away, 2 standard deviations away, and 3 standard deviations away from the middle, from the mean. And we calculated, as in the mathematicians in general, found that when what standard deviation is based on is it will say here that 68% of data is within 1 standard deviation away of the mean. So this and this, all the data that falls in these bins here and here, that is 60%. 68% of data is within 1 standard deviation of the mean. So if I were to divide that in half, right? There's going to be 34% over here, and 34% of all the data is going to be over there. like that's where your data is. So I can say 34% is between the mean and one standard deviation above. 68% is between there. The next one, I'm going to do another color, is, let's go green, between two standard deviations away. So if I were to go, oh man, this one doesn't really work as well. Oh, man. So if I were to do the green, green, yellow, yellow, 95% of all my data is going to fall within two standard deviations of the mean. Falls within two standard deviations of the mean. And the rest of it, I hope you can guess, is very, very much a lot of the data. So if I were to do all of these colors between three standard deviations of the mean, including all the pink pieces, all the green pieces, and all the yellow pieces here, that's going to be almost all, 99.7% of all data will be between three standard deviations of the mean. Let's fill in these other marks here. Okay. So if this is 95% of all my data is here, 68% is right there. So if I go 95 minus 68, that means there's 27 percentage in these two places. If I divide that by 2, I'm going to get 13.5%. Okay. So a lot of my data. And then let's talk about these little pink ones. So 99.7. If I had 99.7 all of my data minus this 95% here in the middle, 4.7 divided by 2, over here I'm going to get 2.35% and 2.35%. Okay, if I were to add all of those up, right? 2.35 plus 13.5 plus 34 times 2, 99.7. So if I were to add up all of these pieces, I'd get 99.7% of the data. Now that's not 100%, right? There are still, like over here, the plus 4 standard deviations away from the mean there. It's possible there's an outlier over there, outlier over there. It's possible. But most of your data is within 3. Now, I don't really feel like that always makes a lot of sense until we see an example. But this is kind of how we're going to be able to talk about where a data point is, why a data point is significant, if it's similar to the majority or not, things like that. So let's talk about dog weight. So let's say I have a dog weight is normally distributed, maybe in just like a doggy daycare place, with a mean weight of 65 and standard deviation of 5. Draw your normal curve, and then we're going to ask a bunch of questions about it. So here's my normal curve. Your middle line, your mean is 65. And from there, my standard deviation is 5. So the next line away is going to be 5 away from 65. So 65 plus 5 and 65 minus 5. Your next line, 2 standard deviations away from the mean, is going to be 5 above and 5 below. And your next line, 3 standard deviations away from the mean, is going to be 5 below and 5 above. Okay? So this is my spread of dog weight. Now I can ask a bunch of questions about like what percentage of dogs would lie where. Starting with some nice ones. So 68% of dogs weigh between what and what? So I know 68% of my data is one standard deviation away from the mean. So here I could say between 60 and 70 pounds. Sorry, I didn't say this is pounds. 68% of dogs weigh between 60 and 70 pounds. I could also ask, how about 50% of dogs weigh below what? 50%, half. Half of the data on the left, half of the data on the right. So half of the dogs weigh below 65 pounds. But I can also get some numbers that you might not recognize, right? What if I said, let's see, I'm going to bullet these. What if I said 47.5% of dogs weigh between what? 47.5, I don't necessarily recognize that number. It's close to 50. But using the numbers that I've got, right? 68, 95, 68 divided by 2 is 34. So it's going to be more than 34. What about this section? What about 34 plus 13.5? 47.5. So two answer choices here. I could say they weigh between, let's see, this is 34, this is 13.5, between 65 and 75, or this is also 34 and 13.5, between 65 and 55. All right, now let's say I wanted to do it backwards. Let's say I wanted to do it backwards. So what percent of dogs weigh less than 60 pounds? What percent of dogs weigh less than 60? So I'm looking at this part of the graph here. Less than 60, couple different methods. You could go like 50% minus 34 or 100% minus 50 minus 34. Yeah. So I'm going to go 100% of all dogs. If I took all dogs minus half to get me to 65, minus 34% of the dogs will give me, gosh, I didn't do this before. I said 16. 16%. 16% of dogs weigh less than 60 pounds. What time is it? Okay. Now, I can also say, if I wanted to do, like if I didn't give you one that fell on the bars, like if I said, how many, let's see, standard deviations away from the mean is 80. So 80 is 2, 3 standard deviations away from the mean, right? Well, let's say I said the same question, same question. How about 57? So that's not on this chart, but it's going to be like more than -1, less than -2, right? It's going to be somewhere in here, 57. So what we're going to do is called a z-score. So a z-score is how many standard deviations from the mean are you? You calculate it like this. Whatever your data point is, minus the mean, divided by your standard deviation. So in this case, 57 minus 65 over 5. Let's do it. 57 minus 65 divided by 5. Negative 1.6 standard deviations away from the mean.